Welcome to SAM Official Tech. Today, we embark on an epic journey into the final frontier, space. From landing on the moon to dreaming of colonizing Mars, humanity has always been fascinated by what lies beyond our planet. In this video, we're going to dive deep into the history of space exploration, the advancements we've made, and the exciting future missions planned for the coming decades. Whether it's astronauts walking on distant worlds or robotic explorers roaming other planets, the quest to explore space continues to evolve. Buckle up as we explore the incredible story of space exploration, past, present, and future. Space exploration began as a competition between two superpowers, the United States and the Soviet Union. The launch of the Soviet satellite Sputnik in 1957 marked the start of the space age and the beginning of the space race. Both nations aimed to demonstrate their technological prowess by sending satellites, animals, and eventually humans into space. In 1961, Soviet cosmonaut Yuri Gagarin became the first human to orbit the Earth, followed by the American Apollo program, which successfully landed humans on the moon in 1969. These early missions laid the foundation for the exploration of space and established space as a new frontier for science and discovery. The Apollo program remains one of the most iconic achievements in human history. Initiated by NASA in the 1960s, its goal was to land a man on the moon and return him safely to Earth. On July 20, 1969, Apollo 11 achieved this goal when astronauts Neil Armstrong and Buzz Aldrin set foot on the lunar surface, uttering the famous words, "That's one small step for man, one giant leap for mankind." The Apollo missions provided invaluable data about the moon, its geology, and the potential for future exploration. Although the last Apollo mission flew in 1972, the legacy of the program continues to inspire space exploration efforts to this day. After the success of Apollo, NASA shifted its focus to creating a reusable spacecraft that could carry humans and cargo into low Earth orbit. This led to the development of the Space Shuttle program, which operated from 1981 to 2011. The Space Shuttle enabled a wide range of missions, from deploying satellites and space telescopes to constructing the International Space Station (ISS). It also made spaceflight more routine, although not without risks, as evidenced by the tragic Challenger and Columbia disasters. The shuttle's legacy lives on in the ISS, a collaborative international effort that continues to serve as a research hub in orbit. The International Space Station (ISS) represents one of humanity's greatest achievements in space collaboration. Built through partnerships between NASA, Roscosmos, ESA, JAXA, and CSA, the ISS serves as a permanent laboratory for scientific research in microgravity. Since its first module was launched in 1998, the ISS has hosted astronauts and cosmonauts from around the world, conducting experiments that have advanced our understanding of biology, physics, and space science. The ISS also serves as a testbed for the technologies and systems needed for future deep space missions, such as trips to Mars. Its continuous operation is a testament to what humanity can achieve when nations work together. While humans have only ventured as far as the moon, robotic explorers have traveled much farther. Robotic probes, rovers, and orbiters have been essential in exploring our solar system, gathering data about planets, moons, asteroids, and comets. NASA's Mars rovers, such as Spirit, Opportunity, Curiosity, and Perseverance, have revolutionized our understanding of the red planet by analyzing soil samples, searching for signs of ancient water, and preparing for future human exploration. Beyond Mars, missions like Voyager, New Horizons, and Juno have given us stunning insights into the outer planets and even ventured beyond our solar system into interstellar space. Mars has long been a target for exploration due to its potential to support life and its similarities to Earth. While robotic missions have already provided a wealth of information about the planet's surface, atmosphere, and history, the ultimate goal is to send humans to Mars. NASA's Artemis program, along with private companies like SpaceX, aims to pave the way for crewed missions to Mars by the 2030s. The challenges are immense, including long-duration space travel, radiation exposure, and establishing sustainable habitats. But the dream of sending astronauts to Mars drives continued innovation in space technology and exploration strategies. One of the most transformative developments in space exploration has been the rise of private companies like SpaceX, Blue Origin, and others. SpaceX, founded by Elon Musk, has revolutionized space travel with its reusable Falcon rockets, drastically reducing the cost of launching satellites and cargo into space. In 2020, SpaceX made history by launching astronauts to the ISS aboard the Crew Dragon spacecraft, marking the first time a private company had achieved such a feat. The commercialization of space is opening up new possibilities for space tourism, lunar exploration, and even the establishment of permanent colonies on other planets. NASA's Artemis program is a bold initiative to return humans to the Moon by 2025, with the ultimate goal of establishing a sustainable presence on the lunar surface. The lessons learned from the Artemis missions will be crucial for future human exploration of Mars. Artemis will also see the first woman and the next man set foot on the Moon, marking a new era of lunar exploration. Unlike the Apollo missions, which focused on short-term landings, Artemis aims to build a lasting lunar base that will serve as a hub for scientific research and deep space exploration. Space tourism, once the stuff of science fiction, is now becoming a reality. Companies like SpaceX, Blue Origin, and Virgin Galactic are working to make space accessible to private citizens. In 2021, Blue Origin successfully launched the first fully civilian crew into space, while SpaceX's Inspiration 4 mission took a group of private astronauts on a multi-day trip orbiting Earth. As space tourism technology advances, we may soon see commercial flights to the Moon and even Mars. However, there are still significant challenges to overcome, including the high cost and the need for safety and regulatory frameworks. Life aboard the ISS or during space missions presents unique challenges. Astronauts live in microgravity, where everyday tasks like eating, sleeping, and even using the restroom require special adaptations. Exercise is critical to prevent muscle and bone loss, and astronauts follow strict routines to maintain their physical and mental health. Advances in space medicine and technology have made it possible for astronauts to live and work in space for extended periods, but long-term missions, such as those to Mars, will require even more sophisticated life support systems and medical solutions. Colonizing other planets has been a long-standing dream for humanity. Mars is the most viable candidate for colonization, given its proximity and potential for supporting life. Building a colony on Mars would require solving numerous challenges, including providing water, food, shelter, and protection from radiation. Technologies such as 3D printing for building habitats, along with innovations in renewable energy and life support systems, are being developed to make colonization possible. While it may still be decades away, the idea of humans living on another planet is no longer purely speculative. One of the most exciting aspects of space exploration is the search for extraterrestrial life. While no direct evidence of life has been found, scientists are exploring planets and moons within our solar system that may harbor life. Mars, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are of particular interest because of their subsurface oceans and signs of potential habitability. Future missions, such as the Europa Clipper and Mars Sample Return, aim to search for signs of microbial life and help answer one of humanity's oldest questions: are we alone in the universes? Space telescopes like the Hubble Space Telescope have revolutionized our understanding of the cosmos by capturing breathtaking images of distant galaxies, nebulae, and other celestial phenomena. The upcoming James Webb Space Telescope promises to take this exploration even further, peering into the earliest moments of the universe and searching for habitable exoplanets. These telescopes allow scientists to study the structure and evolution of the universe, investigate black holes, and search for clues about the origins of life. The data collected from space telescopes continues to push the boundaries of human knowledge. Space exploration is not a solitary endeavor, it requires global collaboration. The ISS is a prime example of this, with space agencies from the US, Russia, Europe, Japan, and Canada working together for over 2 decades. International partnerships will also be critical in future missions, such as those aimed at exploring Mars and the outer planets. These collaborations allow countries to pool resources, share expertise, and tackle the immense challenges of space exploration. As space becomes more accessible to private companies and emerging nations, the need for cooperative frameworks will only grow. Exploring deep space presents significant challenges, from the vast distances to the dangers posed by radiation, micrometeorites, and the psychological toll of isolation. Space agencies are developing new propulsion technologies, such as nuclear and ion engines, to shorten travel times and make deep space missions feasible. Additionally, research is ongoing into creating habitats that can protect astronauts from the harsh conditions of space. Overcoming these challenges is critical for future missions to Mars, asteroids, and beyond, as humanity pushes the boundaries of its presence in the universe. Looking ahead, humanity's ambitions stretch far beyond our solar system. While interstellar travel remains a distant dream, missions like Breakthrough Starshot aim to send tiny spacecraft to the nearest star system, Alpha Centauri, within our lifetime. The discovery of potentially habitable exoplanets has sparked interest in finding new worlds where life could exist. In the coming decades, advances in propulsion, robotics, and space science may enable us to explore beyond our solar system and take the first steps toward becoming an interstellar species. Space exploration is one of humanity's greatest endeavors, pushing the limits of what is possible and opening up new horizons for science and discovery. From the first steps on the moon to the dream of setting foot on Mars, each milestone brings us closer to understanding our place in the universe. The future holds endless possibilities, from colonizing distant planets to discovering life beyond Earth. By continuing to explore space, we not only unlock the mysteries of the cosmos but also ensure a brighter future for humanity. Thank you for joining us on this incredible journey through the history and future of space exploration. Be sure to subscribe to Sam Official Tech for more fascinating content about technology, space, and the wonders of science. Don't forget to hit the notification bell, so you never miss an update. We have so much more to discover about the universe, and we can't wait to share it all with you. See you in the next video.